Hello everyone and welcome back to another interesting topic in AWS. The next topic we are discussing is Lambda, working with Lambda in AWS. Okay, so Lambda basically falls under a category called serverless computing. So let's understand what is serverless computing and what is the significance of Lambda in that scenario. Now before we go there, let me show you in the AWS management console, where does Lambda fall in? I mean, in which category, right? We have all the categorization of the services. So are you able to locate the category for Lambda? Are you able to see that in the compute section? Are you? Right? There you go, somewhere here, isn't it? So Lambda does fall under compute, and we know when do we need compute services from any cloud service provider, isn't it? And AWS is not different from that. We need to go for compute whenever we want to execute some piece of code, right? So that's the reason why we take compute kind of service from our cloud service provider. Now when I say execute some piece of code, naturally what we know about compute so far is we provision some kind of compute resources like EC2 instance and then deploy our code or our application in that instance. And then if you recollect, that instance must always be in a running state in case you want to use the services of the application deployed in that EC2 instance, isn't it? It must be running say 24/7 in case you don't know when will a client request arrive, isn't it? As simple as that. But running a typical application like a web server 24/7, okay, that is something which is understood, and that is also the need of the hour as well. But imagine there is some piece of code which is executed sporadically, okay. Basically it's not running, or it is not required to run 24/7. It is required to run only when there is some event of our interest, okay. Maybe some database modification, or maybe some upload in an S3 bucket. In such case, I want to execute some piece of code, okay. Otherwise I don't need that piece of code to be always running 24/7, okay. If this is the requirement, then deploying such code in EC2 is not gonna meet your requirement, okay. To be very simple and very specific here, when you deploy in EC2, okay, irrespective of somebody uses that application service or not, are you always charged for that instance which is running? What do you say? Are you always charged for that instance which is running? Isn't it? Yeah. Now that is something basically we wish to avoid. Okay. So what we wish to do is, I want to deploy some piece of code, but I want it to be charged only when that code is executed. Otherwise, I don't want that code to be charged. I mean, I don't want code to be executed. So naturally, I don't want it to be charged. Okay. So that is where the concept of serverless computing comes into the picture. So let's talk about what is Lambda here. Okay. So Lambda is a compute service. Of course, we know that. We just saw that here. Lambda is a compute service. And what is the significance? Is a compute service that runs code without provisioning or managing servers. Now that is something which is very interesting, okay, without provisioning or managing servers, and that is why, okay, we popularly place this in something called serverless compute category, okay. Now mind you, and be careful here with that term called serverless, okay. When we say serverless, it doesn't mean we don't need service, okay. Serverless simply means we don't provision or manage the servers. It is a cloud service provider which does that on our behalf, okay. So just to make you guys understand this concept of serverless, let me take you to the concept in programming world. When people say languages like, let's say, Java or Python, right, they say these are platform independent languages, correct? Now what do you mean by platform independent? Does that mean we don't need a platform for running these kind of applications? Does it mean like that? What do you say? Is that the meaning of platform independent?
No,
No, right? So what could platform independent mean in such case? What could be the meaning
like
of?
you don't have to worry about the intricacies of the platform, and you can develop without
Yeah.
and
That's right. So basically, platform independent implies we don't care what is the underlying platform. Could be Windows, could be Linux, could be Mac OS, or any other supported platform, isn't it? So that is the meaning of platform independence. So basically, it promotes the concept of something called write once, run anywhere. Right? It's called WORA, WORA. Write once, run anywhere. Similarly, when you talk about serverless, which okay, um, practically might mean we don't need a server. No, it doesn't mean like that. Okay, serverless basically implies you don't need to provision or manage the servers. Okay, or basically the compute. So whatever is needed is provided by the cloud service provider. So the compute is provided, and within that compute our code gets executed, as simple as that. Okay, so the Lambda service executes our code only when needed. Now pay attention to that. Executes our code only when needed. Okay, and if there is lots of demand, it will scale automatically. Okay, from few requests per day to thousands of requests per second. Now just imagine the kind of scaling that is taken care inside the AWS environment. Okay, from few requests per hour to maybe thousands per second, who knows. Okay, so Lambda executes our code, and naturally in order to execute the code we need compute, isn't it? So Lambda provides the compute, and we don't have to provision or manage that compute. Okay, now interestingly, since we are not provisioning that compute, we only pay for the compute time which is consumed. Okay, so you are not charged 24 by 7, you are only charged for the number of executions and the amount of time taken for each execution. Okay, that is taken into consideration. Okay, we only pay for the compute time we consume. There is no charge when the code is not running. Okay, as simple as that, isn't it? This seems to be quite interesting approach, right? There is no charge when the code is not running. So typically, when is the code running? Well, that is something that we have to configure, okay, as some kind of a trigger for that code to execute. Okay, so with Lambda, we run code virtually. We can run code virtually for any kind of backend service, okay, with zero administration. You don't need any administration. You just need a bit of configuration, and that too, if you are not happy with the default or what they say built-in configurations, then you go ahead and do a bit of configuration. There is no administration, right? It's basically zero administration. Now all the things that we have the benefit in terms of cloud, like high availability, scalability, isn't it? Worrying about management or upgradation or security updates and patches of that platform. No, nothing of that is our concern. Okay, everything is taken care by AWS, right from hardware to operating system to the relevant platform where the code is executed. Right, everything is taken care by AWS. So is it sounding quite exciting here when you listen to all this, isn't it? So AWS Lambda runs our code on high availability compute infrastructure. Okay, so lots of technical terms creeping in, isn't it? High availability compute infrastructure, and performs all the administration of compute resources, including server, operating system maintenance, capacity provisioning, automatic scaling, monitoring, logging, and whatnot, isn't it? So everything is taken care by AWS. Now what is left for us to do then? Well, you recognize the need of what has to be executed. Okay, you recognize what should be the triggering event, and according to that event the code will be executed. Okay, so all that we need to do is supply our code in one of the supported languages. Okay, and that languages list is also quite interesting. So if you look at these languages, okay, last time I saw these were the supported languages. Okay, we'll have a look later in the console in case they have added any other language there, but I guess this more or less covers the spectrum of most of the languages used in the enterprises, isn't it? So we have Java there, Go, PowerShell, Node.js, C Sharp, that will take care of the .NET fans, isn't it? Then we have Ruby and Python, right? So from my experience, what I have observed, mostly, okay, Node.js and Python are mostly used. Next comes Java, C Sharp, Golang, okay, because what happens, there is lots of legacy code and people don't want to rewrite the code. Rather, they just want to write wrappers around the existing code and use in the modern environment. Okay, so this kind of, that is where Java, C Sharp and all that will come into picture. Otherwise, okay, the kind of simplicity and the kind of performance that we are getting in platforms like Node.js and Python, okay, that is actually quite uh, improving day by day as well. So yeah, it is simple and it is supported in the modern day requirements as well. So why not? That is what basically Lambda is all about. So the question is Lambda suitable for all our compute requirements? Okay, the answer is simply no. Okay, it's not suitable for all our compute requirements. So if you want to run something like a web server, which is which is supposed to run 24/7, because we never know when will the client request come, isn't it? So that is where the concept of uh, running 24/7 comes into picture. So Lambda is ideal for many application scenarios where we write the code and we execute the code in spikes. Okay, I'll give you some relevant examples where Lambda is more suitable, but definitely not for those where 24/7 requirements are is the need of the hour. Okay, with Lambda we are only responsible for our code. We know that, we have mostly discussed all this. Okay, AWS takes care of the compute. AWS takes care of, okay, memory, CPU, networking and all other resources. So this kind of flexibility implies there are no compute instances manually provisioned. You don't have to log in and customize the operating system or the runtime. Nothing of that sort is our requirement. Okay, so we just deploy the code, rest all is taken care by AWS. Everything we already discussed that. Okay, so if you need to manage our own compute instances, then obviously there are some better services for that. Okay, if you need to manage your own instances, then obviously EC2 is something which is more relevant, because EC2 offers you some kind of flexibility where you can choose the instance type. Like basically, you know what you mean by instance type, right? How many CPU cores, how much RAM, what should be the root storage block size, do you want to attach any additional volumes? If you want to control all these aspects, then EC2 is more relevant for your requirement. Okay, if you don't care about all this, what you only care is, I have a piece of code, I have some triggering event, that code should be executed when that event occurs. And if there are lots of requirements for executing that piece of code, okay, my provider should take care of the scalability aspect. And of course, there is no downtime, because high availability is something which AWS will take care of. And since it is high available, obviously it is quite resilient by nature. Okay, so that is one aspect. Another aspect which is useful is go for something like Elastic Beanstalk, where you upload or deploy your applications. Okay, you don't have to provision the compute facility like instances. AWS will provision them and start using them. Okay, you deploy, you get the endpoint, and that is what basically you share with the end users. As simple as that. Okay, so other flexible solutions are available in case Lambda is not something that suits our requirement. Okay, as simple as that. So Lambda falls under serverless compute. Again, let me tell you, serverless implies developers don't have to worry about the AWS resources, or they don't have to learn about how to manage them. Just put the code in Lambda and it runs. Okay, as simple as that. So when I say you just deploy your code, that means you are responsible for writing your own code. So you concentrate on your core competency. My core competency is implementing the business logic. My core competency is not provisioning the resources or instances or managing them and securing them. That's not my core competency. I want to understand the business requirement and implement that. Okay, that's my core competency. So AWS executes our code by automatically managing the resources. What do you mean by managing? Sometimes that might be confusing term. Okay, managing implies if required it launches the instance. Okay, and if it feels the instance is idle for a prolonged period of time, the code is not getting executed because there are no triggering event. Again, that is something that you can't determine. Okay, AWS will terminate the instances when they are not required. AWS will take care of the health checks, auto scaling, updating, patching, everything will be taken care by AWS. Okay, as simple as that. So let me repeat, serverless does not mean there is no server. It basically means, okay, somebody else is taking care of your compute resources. So under the hood, AWS uses EC2 instances only. There's no magic formula there. The only thing is you are not managing them. Okay. So let me show you something interesting here. Okay. So look at this and tell me what you understand out of that. So under the hood, your cloud service provider is using compute instances for executing our code. Remember, whatever language you choose, whatever kind of applications you write, without compute, there cannot be code execution. Okay, agreed? So even if you take something like a microwave or a washing machine, or if you take a large mainframe kind of a computer, irrespective of the size, you know you need some kind of compute in order to execute some piece of code. Whether it is a microcontroller in an embedded device or whether it is mainframe, compute is needed. But you don't have to manage that. Your service provider will take care of that. That is what is compute. Have you seen a serverless service concept earlier? Have you seen that? A serverless concept earlier? Think about it. In
Creating tools and assigning rules.
See, S3 is serverless, right? Have we created any storage servers in order to upload our files and documents? Have we created that?
No.
No, we didn't, right? How about DynamoDB? Have you created any instances?
No.
No, right? So services like S3, DynamoDB, right? They're all serverless by nature. Serverless means we don't provision the server. Okay. On the contrary, how about something like RDS? Is there a EC2 instance involved? Yes, there's an EC2 instance involved, isn't it? And we did specify the type for that DB2 instance. If you remember, we talked about DB instance class. Remember that? Isn't it? In RDS, we did discuss about something called DB instance class that tells what will be the number of CPU cores, how much will be the RAM allocated for the instance where the the DB engine will be installed. Correct? So RDS is not serverless. Okay, it is a EC2 again is not serverless, but S3 and DynamoDB, yes, these are serverless. Okay. The moment I talk about serverless, few things should immediately come to our mind. One, we don't provision any servers. Two, since we are not provisioning, we don't manage or update these servers. We don't patch those servers. Three, by default, these services are highly available, right? And because they are highly available, naturally these kind of services are resilient by nature. And Lambda is no different from this. Lambda is also by default highly available. Lambda is also resilient because you don't have to worry about in which availability zone how many computes are provided for executing your code associated with a Lambda deployment. You don't have to worry about all that. Okay, whichever availability zone has the relevant amount of compute, AWS will take care of, okay, providing the relevant compute and then executing your code. Okay, so as simple as that. Now before I tell you more about Lambda, you tell me, as a developer, when you want to write some piece of code, where exactly do we write such code? From the programming language perspective, right? Where do we write such a code? You pick up any programming language. Do you write your piece of code in a function or a method, whatever is the terminology? Okay, let's not go into that discussion of terminology. Do you write some piece of code in a method?
Correct.
Right?
Yes.
Yes.
So whether it is you take a language like C, you write main function, or C++ or Java or C#, whatever, right? You end up writing some piece of code in a function or in a method. Okay. So when it comes to Lambda, when we say Lambda is a service which allows us to upload our code, and that code gets executed upon some appropriate triggering event. Okay, so where is that you write your code, isn't it? So basically the code is in the functions. So when you want to use Lambda as a service in AWS, right, you end up writing certain functions. And those functions, we call it as Lambda functions. Okay. So Lambda allows us to organize our code in functions. And the Lambda service will run our function only when needed. Okay. And because it can take care of the concurrency, Lambda will take care of scaling. Okay, because it is serverless, Lambda will take care of, okay, high availability. And because the code is only executed upon some need and not running 24/7, you only pay for the number of executions, you only pay for the amount of compute time that has been consumed for those many executions. So basically you are paying only when there is execution. You are not paying when the code is not running. Is it true for EC2 instances? If you take the case of an EC2 instance, you are charged for the instance running whether somebody is using the application which is deployed or not. You are always charged, isn't it? That means you are also charged when the code is not running, whereas Lambda is charged only when the code is running. Okay. So there are certain requirements where we feel Lambda is more relevant. Okay, as simple as that. Now forget about AWS Lambda for a minute and tell me, where else have you heard about that term called Lambda? I'm sure many modern languages have that facility, right? Where else have you heard about that term called Lambda? Yeah, Ravi.
I, of course, in physics and all we have heard lambda.
Okay.
But other than that, lambda architecture, we have heard about it. I don't know much about it.
Uh-huh. Yeah, if you look at if you look at many modern programming languages, right? If you take C Sharp or Java or Python, I'm just naming few, okay? There are so many. Have you learnt about the concept of Lambda in those languages? C Sharp or Java or Python, anybody recollects? Have you learnt about Lambda in those languages? If yes, what is coming to your mind? When you use Lambda in those languages, what is that we end up getting? There's a specific term, right? Okay, output. Okay, what else? What else? I mean, this is not what happens in AWS, but I'm just telling you some kind of an equivalent here. Okay. In many languages, C Sharp or Java or Python, whatever, when you write a Lambda, do you end up getting an anonymous function? What do you say?
No.
Isn't it? That's the definition of Lambda. Basically, when you use Lambdas in your languages, okay, whatever is the syntax, let's not bother about syntax, you end up getting something called anonymous function. And you can invoke that function wherever you need that functionality, right? Basically, when you write Lambda, actually you end up writing an expression, and internally your compiler or runtime, whatever, generates a function based on that expression, and that expression executes whenever you invoke the Lambda. Okay, so AWS Lambda basically just borrows that concept of function. Okay, but unlike programming languages, AWS Lambda is not anonymous. Okay, it does have a name. Got it? It does have a name. Our Lambda functions have a name. Without name, rather, you can't even deploy Lambda. Okay, the only thing is they are functions, and those who are coming from some other programming languages, I mean some other cloud platform like Azure or Google, GCP, do you think we have some similar concept there as well? So yeah, how does it all work? So the code that we end up writing, we write something called Lambda functions. Okay, we call it as Lambda function. What we end up writing is a Lambda function. Now we know a function cannot execute unless it is invoked. Am I right? That's what we discussed, isn't it? In programming languages, you write code in functions, methods, procedures, whatever you call them. And then the code executes only when it is invoked. Similarly, in Lambda of AWS, we write code, and interestingly, we don't invoke it. Of course, you invoke it for testing purpose, but in real time, Lambda function gets invoked, okay, whenever the triggering event occurs. And what is the triggering event? that is something that we have to configure. Okay, we know the function runs only when it is called. So here the function invoking trigger is nothing but an event. So whenever some event of our interest occurs, okay, we do lambda configuration in such a way that I want that function to execute when that event triggering scenario occurs, and then the lambda goes for executing. Okay, there is a simple example taken here, and that's a very apt example, I believe. So let's discuss that. Suppose we have an application for image uploading. Okay, so whenever we image and upload, there are lots of tasks to be done before that image gets stored and to be used in the relevant way. Okay, we want to store it. For example, the image needed to be resized, or we want to apply certain filters, certain compression, etc., etc., etc. Okay, for example, you know, some modern mobile kind of applications like Instagram or what's that, Snapchat. Okay, do they allow you to add some kind of filters and some kind of resizing to the images when you upload? Have you heard about those facilities? Okay, have you seen people adding some cat kind of special effects to the photos when you upload? Have you seen that? That's all nothing but post processing, isn't it? Right? So this task of uploading an image can be defined as event source or a trigger. So when you upload an image, that can act like a trigger, and that in turn will result in calling of a lambda function, and then all the tasks which are required to be done on that image can be executed when that lambda function is getting invoked. Okay, so a developer needs to basically has to define what is the event source and configure that as the triggering event for our lambda. Okay, let me take a more simple example to understand. Okay, let me take you to a very popular e-commerce website. Okay, yeah, I'm taking the case of Amazon only. So let's pick up any one item. Okay, doesn't matter which item. Let's pick up one item. Okay, I'll pick up this one. Now left hand side, what do you see here? On the left hand side, what do you see here? Are these all what we call it as thumbnails? The smaller images that you see here, can we call these as thumbnails? On the left hand side, do you see a vertical strip? Can we call these as thumbnails? Isn't it? And when you place your pointing device, or let's say your mouse, on any one of the thumbnail, the actual image will be shown, isn't it? Or rather, the image which was uploaded by the seller will be shown here, isn't it? Right? So imagine a seller wants to add a new item to the catalog. Okay, so seller will upload the item description, seller will upload the item pics. Do you think the seller is uploading the thumbnails? Suppose we see here some, let's say 6 to 7 thumbnails. Do you think seller is actually uploading these thumbnails? No, right? What do you think is the seller doing? Seller is only uploading the actual real sized pics, whatever the manufacturer has provided. Agreed? The manufacturer will provide certain images. So seller will simply upload those images. Now what does the e-commerce website do? From those uploaded images, they will create the thumbnails. And when we go to the particular product, okay, through the catalog, when we go to a particular product, the thumbnails will be visible. And when we place the mouse pointer on the thumbnail, the relevant full-sized image will be shown. Okay. Now my question to you is, when image is uploaded, thumbnail should be created. So the code to create the thumbnail, is it running 24/7? Or should it execute only when there is some image upload? What do you say?
It should only be land is uploaded.
Okay, go ahead. Even others are expressing. Go ahead, guys. There. So basically, this code which will do some post processing on the image need not be running 24/7, isn't it? This code should execute only when some image is uploaded, and that can happen maybe once in an hour, or maybe that can happen 100 times in a couple of hours, isn't it? Imagine many sellers have lots of new items in their catalog now. So obviously there can be many images uploaded, so many times execution should happen. And sometimes it can happen that in a given hour there are no new items added, so obviously no need to execute the code. So when the code for post processing is not executed, why should we pay for non-execution of the code? Okay, or why should we pay for non-running time? You pay only for the number of invocations, you only pay for the amount of compute time that you consume. Okay, that's basically the scenario. So this is where you have to start using these services called Lambda. Okay, only when you want to execute that code. It can be okay, it can be few times in an hour to maybe 1,000 times in a day as well. Okay, so this function is called when there is some event source, as I told you, right? This example, we have an image uploading scenario. When we upload an image, there are lots of tasks involved, such as resizing. Obviously creating a thumbnail is nothing but resizing, isn't it? Resizing the image, applying filters and all those things. Okay, so image uploading is an event source for the, or it can be the trigger, and then resizing of the image is what we write in the Lambda code. Okay, as simple as that. Now this scenario that we just discussed, let us convert that in AWS scenario. So upload an image to some location. What can be that image uploading location? You know, image basically is a static resource, correct? So if it is a static resource, we discussed that and we come to a conclusion. Remember in our S3 chapter that S3 is most appropriate location for storing all your static resources, isn't it? So the destination for uploading the image can be S3, and for post processing we can use Lambda for that kind of a scenario. Agreed? So let's see how does this come into picture. Okay, so this is where I talk about. Let's see that figure, let's understand that figure, then let's discuss about that figure, okay, after some time. Go through that figure, see all the things that you see in that figure. Look at the numbering scheme there, 1 2 3 4 5. We have some numbering scheme there, isn't it? Go through that figure and understand first. Let's try to go through that. So the number 1 in that figure says, okay, user is uploading some image, and assume the S3 bucket is where the image ends up getting uploaded. Okay, so user uploads an image to the source, that is nothing but our S3 bucket, and with that bucket you have a notification attached to the Lambda. Okay, so look carefully, who is notifying the Lambda service? So bucket is on the left hand side, Lambda is on the right hand side. Okay, if you look at your left hand and right hand side, correct? So there you go, bucket, rather S3 service notifies Lambda. Okay, and basically Lambda as a service, got it, is responsible for executing the code, and before that it checks whether you have the right, there is appropriate permissions for the code execution. Okay, that's called execution role. Remember, every Lambda function has an execution role associated with that. In that execution rule, okay, which is basically an IAM policy, we can specify where all the details will be logged about this function and what all resources this function needs access to. All those will be there in the access policy associated with the Lambda execution. Okay, let's try to understand this step by step as 1 2 3 4, something like that. Okay, so let's see that. So number 1, user uploads an image to an S3 bucket which acts like a source. So that's number 1, user uploads to an S3 bucket. Now that bucket has a notification attached to it for notifying the Lambda service. So S3 service is notifying Lambda, okay, that something of your interest has happened here. Okay, S3 is notifying, saying something of your interest has happened here. Okay, so the S3 is deciding to notify Lambda. So S3 sends a notification to Lambda because there is a notification attached to the bucket, so it understands the notification and notifies Lambda. Now this notification acts like a call to lambda function. Okay, now that is something which is interesting. This acts like a call to the lambda function. Okay, got it. So it acts like a call. Now execution role in lambda is defined as an IAM with associated with IAM role, okay, with relevant policies to give permission for AWS resources. So basically the execution role. Remember, every lambda has an execution role associated with it. Okay, what is there in that role? All the resources which lambda needs access to, all that is there in that execution role. Remember our previous session we talked about creating an IAM role. For that, did we create an appropriate IAM policy? Do you remember that? We created an appropriate IAM policy, isn't it? So this execution role is basically something like that. Okay, there basically this role implies whatever permissions are needed for lambda to execute, right? And whatever permissions are needed for lambda to access other resources, all that are specified in the policy. Okay, and what happens? Finally, after verifying in the execution role, okay, the desired lambda function is invoked, which works on the object which was uploaded in the bucket. Okay, when lambda function is invoked, does it need access to the file or the image which the user has uploaded? Does it need access to that? What do you say? Think about it and let me know. Does the lambda function need access to the object or the image which was uploaded? Does it need access to that?
Yes, but that is what is provided through the access policy, right?
Correct. Yeah.
Yes.
Yeah. So that's the second part of the question. So first question is, does it need access to that? Yes, it definitely needs access to that. So how come it should get access? It will get access through the role. Okay. Last week when we discussed about EC2 accessing S3, was the access provided through a role? When we saw EC2 accessing lambda, right? I mean EC2 accessing S3, was that access given through a role? Yes. Similarly, if lambda has to access S3, the concept will still be the same, right? It will not change. You're getting me? It will still need a role in order to access that S3 resource. Like basically the object which was uploaded and that resulted in triggering and invoking of the lambda function, right? So where do you think that permission is given? That permission is given in the form of a policy, okay, which is there in the role, which is used during the lambda execution. Okay, so that's what is step number 4. The execution role in lambda is defined as an IAM role with relevant policies to give permission for AWS resources. Okay, whatever resources lambda needs access to, basically that access is given through the execution policy. Okay, I mean the execution role which has the relevant policies attached to it. Okay, so go through that figure. Now you go to the 5 points which are there. Okay, earlier we only saw the figure, right? Now the figure plus the points. Whether when you every lambda will have an execution role associated with it. In that execution role of lambda, okay, it will have permission to log whatever it wants to log. Whenever it logs, it goes into the CloudWatch. Okay, so it can log into CloudWatch, and then if it needs access to the S3 bucket, which is source of the event, it needs the relevant permission for that. Everything is there given in the form of policies attached to the role, which is used by lambda during execution. That is why we say this is basically a lambda execution role. Remember, when you're creating a lambda function, suppose you go for the console based approach. Okay, a new role can be created at that stage, or if there's an existing role and you feel this role is suitable for my lambda, you can well go ahead and use that existing role and attach it to the lambda during its configuration. Okay, Suppose if you have to solve this using the traditional approach, server based approach, if you have to plan this using server based approach, what do you think are the things that we have to take care of? What do you think we have to take care of? First of all, you need to do the proper capacity planning about how many images are uploaded per hour, how much compute time is needed, and what should we do in order to make sure that the performance does not degrade, isn't it? So these kind of things is what you need to start worrying about. Okay, let me zoom it, and yeah, if we were to solve this scenario, I'm talking about this scenario, okay, I mean this requirement of ours. We have an app for image uploading. Whenever there is an image uploaded, we need to do some kind of post processing activity. If we have to do this using some traditional approach, we have to do capacity planning, provision, and scale the group of servers. We have to manage the operating system updates, security patches, and then we have to do all the monitoring of the infrastructure, isn't it? Everything basically had to be done by us explicitly, right? Of course, we have to make sure about high availability, resiliency, and all these things, isn't it? That is our responsibility, and this would have been quite a tedious task. Trust me, guys, when you're doing all this manually, it would be tedious, it would be expensive, and it would be tiresome as well. So when you go for Lambda, all these things basically get eliminated. Got it? All these things what you see here are eliminated. You don't have to worry about provisioning, capacity planning, scaling, high availability, managing OS updates and patches. None of the things have to be taken care by us. We already discussed that earlier, isn't it? So usage of Lambda for this kind of task is justified. Okay, let me repeat again. Lambda is not suitable when you want to run something 24/7. Okay, suitable only when you want to execute something on some event which can act like a trigger. And of course, there are so many languages which Lambda supports. Choose the one which is most relevant for the given task. Write the code. Okay, zip it, archive it, upload it to the Lambda function, define the event source, and we are set. Finish. We don't have to do anything further. Okay, so we know basically now know how Lambda works and what it does. So where to use Lambda? Use Lambda whenever you want to execute something sporadically, not 24/7. If you want to run something 24/7, there are other relevant services like Beanstalk is used for deploying an application without provisioning infrastructure, but that infrastructure will run 24/7. Okay, why not EC2? Yeah, because if you go for EC2, we have to think of things like load balancing, volumes, where will you store the uploaded images, where will the Lambda store the post-processed images. I mean, if it is not Lambda, where are you storing all that? How are you making it available to the applications? Everything has to be taken care by us. But if it is Lambda, we don't have to worry about it. We just insert the code. We know what is the triggering bucket, and whenever some event of our interest occurs, the Lambda code will be executed. As simple as that. Okay. If our code is running for hours and we expect continuous stream of requests, you should probably go for something else like EC2 or Beanstalk, but definitely not Lambda. Okay, is used for sporadic kind of workload, wherein there will be some quiet hours and obviously there will be some spikes. It will be a mix and match, not 24/7 continuous stream of requests. Okay, so there's a scenario mentioned here. Yeah, just go through that scenario one. Logging the email activity for a small company would require more activity during day than in the night. So there could be days when there are less emails processed, and sometimes the whole world could start emailing us. In both cases, Lambda can be appropriate scenario. Whatever email is received, let's say we are logging that email activity. Okay, obviously you are getting more mails in the daytime and less mails in the night time. Okay, so sporadic activity is happening. So in this case, we can either think of EC2 or Lambda. If you're going for EC2, during daytime there will be more number of servers, during nighttime there will be less servers, because in EC2 scheduling, I mean auto scaling, we can scale based on a schedule. So you define the working hours. So during those hours, let's say I need n number of servers. During the non-working hours, I need maybe less servers. Let's say I need n by 2 number of servers. Let's say during daytime I need 10 servers. During nighttime I need my only 5 servers. Okay, like that. So you do a bit of calculation to get the cost estimation, and then you do the similar cost estimation for lambda. Okay, this is the amount of number of executions happening. Okay, and this is the amount of time which is required. This much amount of RAM is needed for the execution. Okay, how much time the function each execution is happening, how much time each email received can be, how much time is needed for logging that activity. Do a bit of calculation and you come to a conclusion which one is more appropriate. Okay, so it's not that even though the load is sporadic, but if it is taking large amount of time to execute and if it needs more RAM, sometimes lambda can become costly affair. Okay, so considering the use case of a large social networking company where emails are never ending because it has a huge user base, lambda may not be the apt choice. If it is a small company, they may think of lambda. If it is a large company where the company is operating on a global basis, any given time people are mailing it, okay, then obviously lambda may not be appropriate, right? That's basically the concept. So we have to think of what is the use case. We have to think of, okay, how many executions are needed, right? And then do the cost estimation. What happens if I run this 24/7? What happens if I run this in the form of lambda? And figure it out between these two, which one is becoming more cost effective. Okay. Now one thing you have to remember, if at all you are going for something like EC2, remember there is a need of doing updates and security patching manually. There's a need of doing monitoring. Okay, we have to do that. Infrastructure monitoring, okay, maintenance, it's all our responsibility. So sometimes, you know, even though lambda may have the cost same as that of EC2, but for the sheer benefit of zero maintenance, you should basically think of lambda. Okay, because by default lambda is highly available, by default lambda is, you know, scaling, whereas in EC2 we have to take care of all these aspects. That is sometimes which is a plus point in context of lambda. Okay, and moreover, okay, lambda also operates out of certain limitations. So let's understand what are the limitations, and after I make you understand these limitations, we'll have a look at a bit of pricing examples as well. Okay, certain examples are discussed on the AWS official site. We'll have a look at those examples to understand, okay, the pricing in a better way. But before that, what are the limitations of lambda, right? So let's think of the limitations. So here, hardware specific limitations, like every lambda is given a disk size. Got it? Every lambda is given a disk size for temporary purpose that is limited to 512 MB. Okay, I'm talking about the disk size. This is basically called as temp directory. This is available to lambda as temp directory. Okay, that's called temporary. Usually used for temporary, like you want to store something temporary. Lambda needs access to file system temporarily just during execution and all that. But I think this has increased, which is limited. I guess it starts from minimum 512 is given, and I guess beyond that they have doubled it, I guess, or more than that. Sometimes they give up to 10240 also. Okay, this is basically available as temp directory, and this is also called as to be used as what they say ephemeral storage. Have you heard of that? Anyone? Ephemeral storage? Ephemeral storage. What do I mean by ephemeral storage? Anyone? Yeah, ephemeral means temporary, isn't it? So every lambda gets an ephemeral storage. Okay, it can be between 512 MB to, there you go, almost what we can say, and the memory consumed by lambda can vary between Okay, 128 MB to, again there you go, they have increased this a lot. Earlier it was 3 GB, now they have given us to almost 10 GB now. Okay, what do I mean by memory? We're talking about memory consumed by the function during execution. When the runtime launches execution, is some memory consumed or not? Every application has a memory consumed, right? When you start your editor, like let's say Notepad or your MS Word or say Visual Studio Code, it consumes memory, isn't it? When you launch a browser, it consumes memory. Similarly, when Lambda is being executed, it consumes memory. So how much memory is needed for your Lambda to execute? We need to specify that. It can vary between 128 MB to 10 GB. Okay? And then how much time is given to Lambda for execution? It has to complete maximum in 15 minutes. This is called execution timeout. Okay? This is called execution timeout. So Lambda cannot get more than 15 minutes of execution. 15 minutes. Can I say that is 900 seconds? What do you say? Is it 900 seconds? Correct? Isn't it?
Yeah.
So Lambda has to finish its job within 900 seconds. If you feel I'm not able to finish within 15 minutes, then maybe your code is not optimal, or maybe Lambda is not suitable for this kind of activity. Okay? Remember, I told you Lambda is not for running something 24/7, right? You can't go on and on and on. When there is some event, you have to execute that code within a short span of time. That short span of time is 15 minutes. That's called execution timeout. And then something which is more interesting, a Lambda request payload cannot be more than 6 MB. What is request payload? Okay, let's go back to this figure. In this scenario, why is Lambda being executed? Why is Lambda being executed in this scenario? Is it because we uploaded an object into S3? Correct? So, which bucket and what object? Do you think these details should be made available to Lambda? Do you think these details should be made available to Lambda? What do you say? Which bucket has resulted in that event, and what object was uploaded because of which the event was fired? Do you think all these details must be available to the Lambda? What do you say? Should they be available to Lambda? Yeah? When we write Lambda, we are ending up writing functions. Do you think our functions can also need an input? Right? Do you need our functions can also need an input? Yes. So that input has a size associated with it. You cannot go beyond that size. Okay. So your Lambda payload cannot exceed more than 6 MB. What do you mean by payload? Any information which goes to Lambda as event parameters. So put together, all that cannot exceed 6 MB. That's called the request payload. Okay. To be frank, these are not limitations of Lambda. These are called the design boundaries. This is how they have architected Lambda. Okay. To get the best out of the Lambda as a service, they have architected Lambda in this way. So you have to stick to this limitation. Okay. Rather, and this has increased a lot. Earlier ephemeral was only 512. Now they made it 10 GB. Okay. Memory was earlier only 128 MB to 3 GB. Now they made it 10 GB. So the more powerful compute facilities are available, they are increasing wherever possible. But when you are designing your Lambda, you have to keep these things in mind. As simple as that. Now let's understand how is Lambda priced. Okay, the pricing aspect of Lambda and all that. Okay, so Lambdas are priced based on the number of requests that we make to our Lambda function. So basically, how many times is Lambda getting executed? Obviously in a given month, isn't it? Because the period billing cycle is monthly. So how many invocations are happening? If I tell you number of invocations per hour, obviously you have to convert that into per day and multiply that by 30, you get all that. Okay. So number of requests, and during that execution, how much time Lambda took to execute? okay, and how much memory was occupied by lambda. All this put together, the time, the memory, and the number of requests, all this put together is basically what they use as lambda. What do I mean by number of requests? Number of requests means number of executions, as simple as that. Okay, when is lambda requested? Obviously when it has to be executed. So number of executions for lambda. Okay, so lambda counts each request time to start executing whenever it is invoked, right from invocation till the lambda returns. All that put together is the invocation. Okay, and the interesting aspect is lambda available in the free tier? Let's say /free. Did anyone observe that so far? Is it available in free tier? If yes, what are the facilities in free tier? This is something which is interesting. Can you look at that box? Anyone? There you go. It falls under always free category. There you go. That's interesting. Always free, but with a limitation. 1 million requests per month are free. Okay, and 3.2 million seconds of compute time is free. Right? So these are the free concepts. So when they create the billing aspect of lambda, these things are taken into consideration, and your billing starts when you surpass these limits. So if you have understood these pricing aspects of lambda, right? So one is the number of invocations, two it's the durations. We understood what is duration, right? It is calculated from the moment our code execution begins till it returns or it terminates, and it is rounded to the nearest 100 milliseconds. Okay, as simple as that. And then of course we have to look at certain pricing examples for lambda. Okay, so let's go to the lambda dedicated page. So aws.amazon.com/lambda. If you go to this page, and if you look at the top, we have a pricing tab there. So let's go to pricing tab. They tell you on what basis lambdas are priced. Okay, go through that later. We already discussed a bit of that to understand that in a better way. And if you scroll down, there's a pricing calculator. Okay, there you go. The cost is given here with respect to US East 2, but more or less, okay, there's a slight variation, but you'll better get an idea. Okay, this is the Intel AMD price, and this is ARM price, basically architecture. Okay, and if you scroll down, ephemeral storage pricing, right? I told you know what is ephemeral storage, isn't it? Something which lambda needs as a temporary storage. There you go. So how much have you configured? This is per GB cost. Minuscule, but still everything counts up in the end, you know that. And there are some examples given here. There you go. 3 examples are given here. So I would like to run through these examples to understand pricing in a better way. Okay. So I want you to first go through this scenario. Then we'll discuss the pricing aspect given here. They have given the pricing here. Okay. The monthly charges are given here. So first you go through this scenario. That's important. Go through that scenario first. You are a mobile developer, okay, building a food ordering app. That's interesting. In this line, right, how many parameters are covered here? 3, right? What do you say? For this given scenario, this is the monthly cost you are getting, $2.33. After removing the free tier quota, okay, I mean forever free service is there, no? So I have removed that free tier from here. There you go. That is the free tier. Removed it. $2.33, okay, is the monthly charges for running lambda function for this kind of a scenario. Okay, you feel lambda is quite economical, but that may not be always the scenario. Okay, because the time consumed for every execution and the memory consumed is very less. Okay, let's have another example where there is some other scenario discussed here. Okay, a logistic company with a fleet of vehicles, blah 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 blah. Okay, basically the vehicles are generating some data, telemetry data from sensors, and that basically is uploaded, and that uploaded data is processed by Lambda. Okay, so let's see here. There are 10,000 vehicles, each emitting telemetry data once in an hour. Okay, once in an hour. So how many times in a day? Obviously 24 times, isn't it? You intend to perform some inference on that payload. The function occupies 512 MB in size. Okay, that's the function size, and the configuration of your function needs 1 GB of RAM. Okay, the function execution is 2 seconds. Now there you go. That itself is a huge time here, 2 seconds. Earlier example said only 120 milliseconds, isn't it? This says I am executing that each execution takes 2 seconds. But obviously the memory required is quite less. So let's go through and understand first of all total how many executions are there in a month. 10,000 vehicles, each vehicle generating 24 times data in a day. There are 31 days in a month. So 10,000 into 24 into 31. Okay, there you go. These many number of messages will be processed by Lambda. Okay, so this is basically monthly request cost, because this is per invocation. We have no costing here. There you go, $0.20 per 1 million invocations. So there you go. This is per million this is invocation charges. Now you have to compute charges. So what are the compute charges? 7.44 million. Each execution takes 2 seconds. So those many million seconds. Okay, multiply that with GB. So 1 GB RAM is configured. So 14.28 GB seconds. 14.28 plus per GB second cost is this much. Okay, and then you add these two charges. There you go. This is what it is coming to. Of course, here they did not remove that free tier, assuming this is beyond that free tier scenario. Okay, then the Lambda cost is coming is almost okay $250 per month. So this is second example. Look at the difference between first scenario, how much it is coming to per month. Look at the difference here, how much it is coming per month. There's a huge variation, isn't it? Because here the number of invocations were only 2 million counted. After remove 1 million free tier, 2 million are left. Here they didn't remove free tier, because assume free tier is already consumed by some other Lambda function. So obviously we are counting all 7.44. Okay. Now you do a cost estimation. What if there is a 24/7 running EC2 instance? How much that it comes to? Okay, like that. One more example is there. Go through this example also, and things will be more clear here. Let's assume your function is receiving 6 million requests per month. All this is just to understand a scenario. Actual information is here. Assume your function is receiving 6 million requests per month. Average execution time 280 milliseconds. You have configured almost 4 GB of RAM. Okay, and 2048 ephemeral storage. That is also counted, no? You know the ephemeral storage cost, right? Where's that ephemeral storage cost? Ephemeral, we have used 2048 ephemeral storage. That also would be counted. So first you understand how many seconds are consumed, and then how many executions happening. Then you sum this together. So first, okay, how many seconds and how many invocations? So there are 6 million requests. Okay, each request is 280 milliseconds. So multiply 6 million by 280. These many seconds. Okay, first calculate how many seconds are consumed in the entire month. Okay, how much memory is configured? You configured 4096. That means almost 4 GB, right? Divide 4 GB by 1024. Obviously that is 4. So this is what is come to. These many GB seconds. From the free tier they have removed that. Balance is this one. These many GB seconds. This is per GB second cost. Multiply, you will get this one. This is the compute charge. Now number of requests. This is per 1 million cost. So 6 million, out of that they remove 1 million, 5 million into 0.2, $1. That was very simple. Ephemeral cost is also there, right? So 512 is provided at no extra cost. So 2048 minus 512, this much of ephemeral storage, and multiply that with per GB of ephemeral storage. Okay, you'll get this figure. So add all these three. This is the monthly cost of Lambda. Okay, this is total number of seconds consumed, isn't it? This one. So into this GB seconds and multiply that with the per GB cost, you get this one. All this put together. So ephemeral cost is not much, as I told you. Okay, invocation charge is also not much. So lots of consumption comes from this aspect. If you look at the previous example, here compute charges are more, request charges are less. Here if you see carefully, request charges are less, compute charges are more. Okay, so where are you giving more? Always is in compute charges, not in request charges. So compute is determined by what? How much time and how much memory is occupied. So more time, more memory means obviously more the cost. Okay, as simple as that. This is the monthly cost that you'll end up getting. Okay, pricing tab is important for any service. And then in FAQs, you'll get lots and lots of very useful information there. Okay, especially those who are preparing for certification, this information here will be priceless. Okay, but then important things is you need to make a note of all the things that you feel I need to remember in the long run for the preparation. So that was a bit of Lambda introduction. In the next session we meet, we'll start creating our own Lambda function. Thank you.